Hello and welcome back to Black Hole Battles game development here on Let's Code Physics. I've been continuing to work in the background on some possibilities for the controls for our ship, the enemy ship here, the one that's being controlled by the computer. He is successfully avoiding black holes. Under the right circumstances, he might even be able to lead a player toward a black hole. But as I've been working through different scenarios, it occurs to me I don't have a basic subroutine that tells him to go toward a certain point on the map. And that would probably make more complicated stuff easier if I could just say go to point. So what we're going to start working on today is a subroutine that will have the enemy ship go toward a target. Now, the target point, like let's say that might be the player ship. It might be a point directly between two black holes. It might be some point that it thinks that the player is trying to head toward. But the target, let's say, has some range associated with it. So we want the enemy ship to get to this target plus or minus the range. So we want him to get within a circle of radius range about the point target. In order to do that, what we need to do is we need to look at, guess what, another cone. There seem to be a lot of cones in the development of this game. We could call that maybe the target cone, so that if we draw the relative position vector here, so again we'll call that script R in honor of Griffith's electrodynamics textbook. So then in that case the target angle is going to be this angle in here. It'll be half the angle of the cone. And what we can do from there is to evaluate the direction that the enemy ship is pointing. So for example, if the enemy ship is pointing this way, then I want him to rotate toward the target. I don't really want him to thrust, because for him to thrust would be to take him away from the range. So this would be rotate but don't thrust. Thrust. I can do better than that. In the event that my mom is watching, I need to have decently better handwriting than that, although this is not decent handwriting. Whereas if the ship were pointing, let's say in the, let's go with blue here, sure. If the ship were pointing in this direction, then I would want him to thrust, and I suppose I would want him to rotate. It's not really necessary for him to rotate. I mean, he can rotate to get closer to the target, I suppose. I suppose we could set up another range, a minimum range, where we don't worry about him rotating anymore. The problem is if he's pointing, like this way, then he's just going to get over here, but we can correct that and get him closer to the target. Yeah, so I think I like that. I think I like him thrusting and rotating there. So the condition that we need to evaluate there is if the scriptr dot angle, so the angle that this thing is located at, or is oriented at, minus the ship angle. I guess we can call that enemy angle, because we're definitely dealing with the enemy here. So the enemy's angle. And we know how to evaluate that. We've gotten that a number of times before. We can just copy that line of code from elsewhere. So the enemy angle is the direction the enemy arrow is pointing, so the blue arrow or the black arrow here. If that is less than the target angle, right, so if that's within the cone, then we thrust. And otherwise, we don't thrust. Cool. So let's head over to our enemy controls. I'm going to try to remember to zoom in this time. There we go. Let's see. So I need to start a new subroutine here. Oh, not before fixed update. Let's put it after fixed update, just because that seems to be the customary thing to do. So we got void. Let's call this one let's see, we called this one go to next nearest black hole, so let's call this one go to point. Although I suppose it's not necessarily going to point, it's more going toward point. So we need to give it a target, so that's going to be a vector. I think we can get away with a... No, let's use vector 3, yeah. Let's call that target. Go to point, vector 3 target, and float range. So we've got our location here, the target, and we've got our range set up around here. Oh yeah, we'll also need to figure out what the target angle is. So let's do a little right triangle for that one. So here's TA again. So my right angle is going to be in here, which means I've got the opposite and the adjacent. So I need arctangent. So TA is going to be arctangent of opposite range over adjacent, and that's going to be the length of scriptar. So scriptar dot mag. There we go. Cool. And then I need to do an open brace. I need to do a close brace. There we go. Alrighty, so I need to set up target angle. So I need float target angle equals a mathf.atan. And again, I'm going to use the atan 2. That seems to be working better than just atan because it handles the infinities better. So we're going to call that float of the opposite. So I need range, lowercase, comma. Oh, I don't have my relative position vector yet. All right, let's worry about that in just a minute. Target angle. There we go. So then we have target angle. Oops, equals this, comma. What did I do there? Oh, I pasted it twice. Excuse me. Range, comma, rvec dot magnitude, and it's going to yell at me because it doesn't know what rvec is. We're going to take care of that in just a minute. Okay, I need to get the rvec, so I need a vector 3 rvec gonna equal, I need to take, let's see, it's always the point you're going to minus the point you're coming from, so that's gonna be target minus the ship's position, so I need transform dot position. All right, everything's legal now. Okay, and so then the next thing I need to do is I need to get the scriptar angle and the enemy angle. Oh wait, I did get the scriptar angle. Or excuse me, I did get the, yeah, I got the target angle. I need to get the scriptar angle. So I need to define a float rvec angle equals another mathf.atan2, copy and paste. And so this is going to be its y over its x. Yeah. So I need to get rvec.y, comma rvec.x. Cool. It has put in the automatic spaces to say that it approves of what I just entered. It's amazing how quickly I respond to positive reinforcement. All right, we've got scriptar angle. Now we need to get the enemy ship angle. Let's see, we've got that somewhere down here. Where do we have that? That should be with all the, here we go. Let's see, and this is all under go to next nearest black hole. Yeah, this is the one I want. Is ship angle, ship's current orientation angle, and then it does all the magic transformations that it needs. Let's see here. Keep going, Brian. There we go. Now we have our ship angle. Ship's current orientation angle, just based on the ship's initial orientation being downward, and blah, blah, blah. Okay. We are ready to make our evaluation. So if mathf.absolute value, and we're going to take rvec angle minus ship angle Oh, and I think I need to have all this in parentheses, is less than the target angle. Again, the absolute value is important so that it doesn't matter whether the ship is, whether the blue arrow points on this side or on this side. That all takes care of it, you know, being within that cone. Target angle. Oh, not a thing there. Then we need to thrust. And then we need an else. And we'll put this in just in case. Don't thrust, just to be explicit with it. Cool. And then we'll put in the rotate ship here. Here, let's say this determine thrust. All right, cool. So the way we've got thrusting set up now, remember we made the subroutine that automatically does the applying of the thrust. So let's copy and paste that into the end of the code, or end of the subroutine. There we go. Apply thrust, thrust controls dot apply thrust, and a thrust direction with a thrust mag on the rigid body 2D, add it to the force on the ship. Great. And then I need, okay, so thrust direction is either equal 1 or 0. So thrusting means, well, first let's declare the variable float thrust direction. That now makes that happy, okay? And I'm going to copy and paste that just so I don't have to worry about spelling it. Thrust direction equals 1, and we made that, we made that an int in the subroutine, just to make sure our 0 is 0. Let your 1 be 1 and your 0 be 0. Let's see. Thrust and don't thrust. Okay, cool. Now we need to rotate the ship. And this is where we worry about all the helicity and everything. So let's see. I've got here whether it needs to go clockwise or counterclockwise, and then it assigns the rotation direction. I'm always going to be rotating toward, so I want rotation direction to equal 1. And then helicity flips it. Okay, so I need to copy those 3 lines. So here we're going to do the rotation. I probably need to make an apply rotation just like I have an apply thrust. But I have not done that yet. So let's see here. So there's the helicity calculation. Float rotation direction equals 1. Because we're not going to be rotating away from point. I suppose you could make a subroutine go away from point. That might be worthwhile. I mean, I guess the only thing you'd want to avoid would be a black hole, and we've already got that code taken care of. Well, anyway, let's finish this by getting the helicity correction, because helicity just tells you whether you want to rotate clockwise or counterclockwise. Copy, and I don't know why I called it an H value now. The meaning of H is lost to me. Flip, why don't we call it flip rotation? Based on helicity relative to target. There we go. And now the beautiful thing is I could now replace part of a void black hole and go to nearest black hole with this go to point and just have the black hole be the point, because now what I could do is I could call this subroutine and have the target be the location of the black hole and the range be the width of the black hole. So now I could simplify some of those other codes below. Okay, so we are applying our rotation. Oh, actually, we're not applying our rotation yet, are we? Because that just gives us rotation direction. And then I still need to actually rotate the ship. Copy. And then we've got thrust controls being applied there. Okay, I have a lot of stuff commented out that I can probably get rid of at this point. For cleanliness' sake, I think I'll move the apply thrust up here to after we determine the thrust. There we go. Then let's call this determine rotation. determine rotation. So yes, we got determine thrust, apply thrust, determine rotation. I suppose the next thing needs to be called apply rotation. Cool. Alrighty, so we've got transform.rotate. Good, good, good. Okay. So everything is working out fine here. It's not showing me any red underlines for errors, and I don't see any errors on the Unity compiler over here. So let's make sure everything is saved. And let's do this. Let's have the enemy ship chase the player ship. Here's what I'm going to do. Do I have the player defined up here? I do not. Okay, where do I define the player? Oh, I do define a game object player there. Oh, right. I've got the am I being chased now. Oh, yes, thank you. Let's see, I must remember to mute my push bullet. Let's see here. Okay, so here we've got the being chased, etc. I'm going to comment that out for now. Control-Alt-C, yes. And what I'm going to do is I'm going to say go to point. There we go. It's been accepted as a subroutine. I need a target. That's going to be player.transform.position, comma, a range of, I guess let's make it player.render. Gosh, I just want to access the player's size really quickly. Player.collider new game object dot. Why are you not letting me have a collider? I just want to get the width of the thing. All right, then let's give it. All right, let's just do it manually then. So let's see. This is each one. So let's give it a range. Yeah, let's give it a range of 1. Sure. Okay, so what it's going to do now is each frame, because this is all in fixed update, it is now going to thrust toward the player. Now that means I can lead him into a black hole really easily, so this guy's going to die pretty easily. So let's watch the screen over here. He's rotating. Oh, now he's thrusting toward me and right into a black hole. Okay. So I guess one way I could do it would be to have him, but that's really weird. Why is he? Okay, so this one should be easy now, right? He should be heading right toward me. Okay, why is he not swinging back the other way? Okay, so this will determine whether he's thrusting. So let's say print thrusting. Print not thrusting. There we go. I think that's legal. Then we'll apply thrust. Cool. And then we've got determine the rotation. I might have this set up. Oh, I don't have anything defined as angle. Okay, my bad. This needs to be ship angle. This needs to be ship angle. Save. All right, let's try that again. Not thrusting. Now he seems to be stuck. Enemy, why are you not rotating? Bro, why are you not coming at me? Okay, so let's try let's try another diagram. So here's target, and here's the enemy. Okay, now if he's pointing this way, right, then that means, and RVEC goes this way. Oh, yeah, just call it RVEC. And RVEC goes that way. And here's ship angle. then what that means is he needs to be rotating this way. He needs to rotate, that would be clockwise. Okay. If he's pointing this way, then he needs to rotate counterclockwise. And so the way I determine that is by taking a cross product, right? So the thrust direction needs to equal the sine, SIGN, of the cross product. Let's see, it needs to be ship angle cross thrust. Yeah, so it needs to be SA X component times R vec Y component minus SA Y component times R vec X component. What do I have over here? Oh, why do I have cosine of ship angle? Let's see. Yeah, that will give me the X component. That will give me the Y component. Oh, you know what? Why do I have two negatives on this? Oh, this was based on the old definition of ship angle. Hang on. That should be a step in the right direction. I was going to say that should fix it, but that should be a step in the right direction. So there's my cross product. Yeah, so let's give that a try. First we save the code, then we run the code. There we go. Okay, he's pointing the exact opposite direction of me now, which suggests to me that I just need to flip a sign. Save. Ooh, and he's thrusting. He's thrusting. He's headed right for me. All right, let's see if he follows. Does he follow? Okay, he's rotating around the wrong direction. There we go. Now he's following. I got to avoid black holes along the way. He doesn't... Why is he not thrusting? And if he's not thrusting, why is he not rotating? Let's do one more thing. Print rotation direction dot toString. Let's do that, and then we'll see what... Oh, you... No? Okay. All right, let's see what we get for rotation direction. Okay, so right now it's alternating between 1 and -1, which is what I would expect. Oh, and he's coming right for me. I gotta get out of here. Okay, pause. Okay, so now he is not thrusting. He should be turning around now. His rotation direction is still flipping back and forth, it looks like. Okay, so I've got some angle refinements. You see, like right now he's stuck going back and forth one way or the other. Oops. So actually, I wonder if I could just use the angles that I've already got to evaluate which direction it needs to rotate, because I've got the ship angle and I've got the angle for RVEC. I've got the difference between those, so I could just evaluate whether that difference is positive or negative. The whole cross product business may be a bit too complicated for it. So let's see. What if I made rotation direction? Oh, I haven't declared it yet. Float rotation direction. Yes, thank you, Java. Appreciate that. Let's mute the computer. There we go. Float rotation direction equals mathf dot. Do you know the sine function, mathf? Oh, I think my... Well, I think it knows the sign function. I think my library crashed or something. Float rotation direction, mathf.sign, and then we just take this angle, rvec minus ship angle. Might need to flip that around. Because let's see, if rvec is greater than ship angle, because it's measuring angles from the x-axis, right? So if rvec is greater than ship angle, then I need it to rotate in a positive direction. And that would give me a positive number there. rvec minus ship angle. If I were rotating it the other way, ship angle greater than rvec, then this would give me a negative number. So that works. But what about stuff below the x-axis? So for example, suppose rvec is going this way. RVEC, there we go. And the enemy ship is pointing this way. Well, no, that's 180. Let's say it's pointing this way. Then I would want it to rotate this way. And that will certainly work because this angle is going to be less than this angle because it likes to go from 0 to pi and then from 0 to negative pi. But then if it is pointing this way, I would want it to rotate this way. And so it's not going to, that setup is not going to work if my angle is in this quadrant. So I guess the best thing to do is to, maybe let's save the calculation for down here. So we'll say if 0, okay. Oh, but then if rvec is pointing up this way, then that's got to change anyway. Actually, there is some... Well, why don't we just try this for right now? See if it's any better than what we have. Rotation direction equals that. Save. Okay. And let's run it. Okay, yeah, it's definitely rotating in the wrong direction. Yeah, I'm under go to point. Okay. So no, that's not working. Yeah, he is definitely rotating away from me. And now he's not thrusting. Why is he not thrusting? He's definitely... Oh, his... Okay. So something weird is going on there. What's the other thing that... Okay, I'm printing rotation direction. Okay, so he was getting stuck. So you notice he was pointing this way. So he's getting stuck between +1 and -1. All right, how did I fix this before? Let's see. When I was doing go to nearest black hole, I had the ship angle. I had the nearest black hole angle, next nearest black hole angle, blah, blah, blah. Okay. So let's see. Well, for one thing, let's try making this the negative. See if that gets him to rotate toward me. Okay, he rotated toward me. He is going to run into the black hole. Okay, this will be a better test case. Okay, he is following me. Uh-oh, I'm about to run into a black hole. I want to see what happens if he ends up pointing in the negative x-axis again. Oh, he ran into a black hole. Maybe I need to just go the opposite way. Back out. Uh-oh, get away, get away, get away. What happened to him? What happened to him? I must know. Oh, that seems to be working. He's actually doing a decent job chasing me. He has not seemed to have gotten stuck here. Pause. Okay, continue. Oh yeah, we just got to get away from the black holes. Follow me away from the black holes. I will lead you to safety. Okay, is he stuck now? No, he's not stuck. Oops. Boom. Oh, man. Uh-oh. Oh, okay. We just had a momentary computer freeze there. What is he doing now? He is thrusting. He is moving toward me. Oh, I gotta get out of here. Okay, well, I don't know how that fixed it. I guess. Yeah, I'm not sure how that fixed it, but it did. So I'm not going to complain. So let's take away one fewer operation. Let's give it one fewer operation to worry about, and just flip it inside here. Save. Double check it. He's actually doing pretty well chasing me. So now the question is, how do I combine him chasing me with... Oh, hang on. How do I combine him chasing me with with avoiding a black hole? Because right now, if there's a black hole in between him and me, you know, I've got him. So, like, I can do this number. Oops, not that number. Not that number. Yeah. So, like, I can do this number right here. Get that teeny tiny black hole in between us. Probably easier said than done. All right, let's get this larger black hole in between us. Well, maybe that is easier said than done. I'm trying to get this black hole in between us. Here, pause. All right, he's over there. I'm over there. The black hole is here. Okay. I'm trying to play off of two screens at once, and that is not easy. Kind of makes me reconsider having a map in the corner. All right. You are persistent, aren't you? Okay, yeah. He ran into this black hole down here. Begone! Begone, enemy! Yeah, so anyway, now I wonder if there is a way to combine the follow this guy, unless there's a black hole in between you. I suppose all I have to do is treat it like the go to next nearest black hole. Oh, perfect, perfect, perfect. Come on. Oh, this way, this way. Come on. Oh. Uh-oh. Uh-oh. We're out in open territory. He can come get me. I mean, nothing's going to happen when he hits me. Although I think I figured out, I think, I was originally not going to have any kind of damage system, but I was talking with a student, and his suggestion was, oh, he is sly. Look at him going around that black hole. Boom. Okay. Anyway, I was talking with a student, and I think a way I might incorporate a damage system would be to have, if ever there's a collision or when you do get hit by an enemy weapon, that your systems take damage, so that so as you're progressing through the levels, you get all these upgrades, like the look ahead or a momentary anti-gravity shield, or faster thrusters or something like that. But as you take hits, you gradually lose your systems, and so you have to constantly reobtain upgrades, and that might actually be a good mechanic to keep the ship from becoming overpowered. So this seems to work. This seems to work out fine for him to head toward a certain location. So I wonder if I could replace some of these. I wonder if I could replace some of these code, some of this code down here with go to point. It's like, for example, going toward the nearest black hole. Well, actually, no, that one you don't want to do, because then you've got to avoid the nearest black hole but go toward the next nearest black hole. So let's actually take out. No, not the thrust part. I can take that out because I've got the thrust controls elsewhere now. Let's take out. Oops, that was under avoid black hole. Let's take out this part of determine rotation. There we go. And I suppose I could replace that with the declaration. I suppose I could put that in the declaration now. Let's just make sure I have not angered the powers that be in C#. Stay away from me. No, I said stay away. I said stay away. I don't like you. I don't know you. Oh. Yeah, I had my eyes on him, not my eyes on my own ship. Okay, so that's fine. Let's see here. We got apply rotation. Cool. So, I think I want to try. Oh gosh, that was easier than I thought it would be. I think I would like to try now doing a negotiation between go to point and avoid black hole. So right now the target is the player.transform.position. So let's do this. Let's check for whether a black hole is between. No, actually, all I have to do is check for whether the nearest black hole is between ship and player. So let's see here. How did I check this? Down here under go to next nearest black hole. Okay, we have the danger angle calculation here. Copy. So we've got danger angle, only now instead of IB, this is going to be closest black hole. I know I call it nearest sometimes and closest other times. My bad. Nearest black hole position, so that would be, let's see, black holes, dot transform dot position dot magnitude, etc., etc. I need to define danger smidge, float danger smidge. Don't go there, smidge. There's danger. Danger smidge. Danger smidge equals. I think I have it as a 1 float. Yeah, so that way it's a total of 2. And then I need to get, because I want to see if I can get him to go around the black holes to come toward me. Which I've already got that structure set up in go to next nearest black hole. So let's see here. Vector 2, next nearest black hole position. Okay, so I've got the danger angle. Now I need the angle between the targets. Copy. And we'll go with paste. So float angle between target and black hole. Boy, that is getting long. Oops, I put that in the wrong spot. Why did I put that in that spot? Control X. Okay, yeah, I want that to go here. Angle between target and black hole is, let's see, your nearest black hole dot position to blah blah blah. So, oops, that needs to be this thing. Black holes, closest black hole, etc. So that's the closest black hole's X position. And then the next nearest, so that now needs to be the, what are we calling this? The player dot transform dot position. And then same thing over here. Black holes, blah, 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 times player dot transform dot position. Cool. Let's get rid of that. We know that that process works. Fingers crossed. So now we say, oh, and then I need this thing to actually take the angle because I took the cross product up here, stored it temporarily. So let's take long name, copy, replace one long name with longer long name. And so here we've got this thing, and now we've got to divide by the magnitude. So this is now going to be this long thing, actually this even longer thing. Copy. Hey, the tutorial I read, or the tips I read, said do not worry about making your names too long. Make sure they make sense. So I am doing that. And paste player.transform.position.magnitude. So now let's do this. If the angle between la 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 la, the novel, oh, and I need parentheses around this, is less than danger angle, then you need to avoid black hole. Let's see here. We need to avoid black hole. Oh, I should have just copied the arguments. Armin want and safety speed. Our closest black hole. Armin want and safety speed. We've already calculated them. Else, oops, please go to point. Oh, I've already got that down here. Here we go. Never recreate code. Okay, cool. So if we are within the danger angle, then it's going to avoid the nearest black hole. Otherwise, it's going to go toward the player. All right, let's see what difference that makes. All right, I almost feel like putting the camera back on the enemy ship for this window. I need to figure out how to do multiple cameras for multiple windows. All right, so he's heading toward me. That's good. Let's try to get a black hole in between us. Okay, we've got a black hole nearby, so let's see what happens. Oh, he's going around the black hole. He might have done that anyway. Ooh, he's coming after me. Oh dear, this is dangerous. I'm getting too fast. I'm getting too fast. All right, let's camp out here. Let's see what happens. As he approaches. Is he approaching? Where is he? Where are you? Okay, he's over there. I'm relatively safe over here. So let's see what happens. Let's see what happens as he approaches me. Okay, you were supposed to go around that black hole, guy. Well, just push me around, why don't you? There we go. What did I do wrong there? Actually, I've probably been recording for plenty long enough. I should probably just take a look at this off camera. let me take just a couple minutes to look at this. So we've got danger angle is math f dot a tan 2. So we've got the closest black hole, its size, comma the positions. Oh no, I don't want that. I need the relative position between the two of them. There's your problem. There's a problem at least. So let's see here. We've got black hole because this needs to be the relative position vector, right? Let me open back up my diagram. Yeah, this is where we calculated it. Yeah, that needs to be because you had R vec and B vec. Oops. Okay, well I tell you what, let me take care of that off camera because that's just some tidying up of the math, and then I'll report back with how that turns out in the gameplay. So I guess I got myself confused about the player angle and all that stuff that I was able to use in this part, but here I need the relative position vector. So here I've got the relative position vectors set up, and then I'm referencing them down here just like I do in the go to nearest black hole. So we've got an actual calculation of the angle between the relative position vector of the target and the relative position vector of the black hole. And so we've got the closest black hole. We're avoiding the black hole if we need to and going to the player if we need to. Save. All right. Let's run it. Oh, he ran into a black hole. Oh, I can't see him. Where is he? He's coming right for us. Evasive maneuvers. Oh, no. I need to survive this. Ooh, look at that. He's avoiding. Oh, he almost avoided that black hole. I'm gonna call that one a partial success. Let's back up. Oh, no, you don't. Oh, no, you don't. Oh, no, I don't. Oh, no, I don't. All right, let's get over here. Let's park on the other side of this black hole. Where is he? Where is he? Pause. Where is he? Okay, he's all the way over there. Okay, so he's got a little bit of traveling to do to get me. Okay, I'm going to try to get like just in position here. But where is that drag force when you need it? No, oh shoot, I was going the wrong way. Okay. Let's see here. Okay. Oh, this ought to be fun. What's he gonna do? Pause. Okay, so now he's over here. And now he's going away from... Okay, so he is going away from the black hole now. I need to put in some print statements to see what he does. Okay, he's turning around now. He must feel safe enough to pursue. Okay, he's coming toward me. Oh, he is coming toward me. I need to get a black hole in between us. Oh, so what he's not checking for is he about to run into a black hole? Okay. So he's turning around. Okay, so currently that's the closest black hole to him, so he shouldn't be worried about that because that's not in the danger cone. Oh, but he's not turning because he's not... Why is he not turning? He's not thrusting, but he should be turning. No, he is turning now. Okay. Okay, I probably need to change the amount by which, the criteria for which he turns. Okay, now he's actually turning away from me. Okay, he must be avoiding the black hole now. Okay, so I've got some fine-tuning to do with that, but this is definitely some interesting behavior. He is capable of pursuing me. He's also capable of pursuing and I can go after him. So this is a pretty big success. This is a lot farther than I expected to get with it. So I'm going to play around with that more off camera and show you what I've got next time. Thanks so much for watching. I will see you next time. Bye-bye.